Welcome to Quiet Universe. Today, we're digging deep, literally. Beneath the frozen landscapes of our planet lies an untouched archive of history, a place where time moves at a glacial pace, preserving secrets that stretch back millions of years. From ancient air trapped in ice to long-dormant viruses waking up after millennia, every frozen layer holds a piece of Earth's forgotten past. But ice doesn't just reveal our history. It could also hint at life beyond our world. The hidden lakes of Antarctica might be the closest thing we have to the alien oceans of Europa. And who knows what else lurks beneath miles of ice? Lost civilizations? Ancient catastrophes? Or something we haven't even imagined? So today, we're going on a journey into the deep freeze, exploring why we dig in ice, what we've found, and what these discoveries mean for the past, the future, and maybe even other planets. Beneath the vast, unbroken expanse of Antarctic ice, where the cold is so absolute that even time itself seems to slow, lies a world that no human has ever truly seen. Imagine the slow, deliberate process of drilling into this frozen abyss, each layer of ice peeling back like pages of a history book untouched for millions of years. The ice is thick, stretching down thousands of meters, each section a frozen moment in time, preserving the atmosphere, the climate, and perhaps even life from an era when the world was unrecognizable. As the drill bores deeper, the pressure mounts, the weight of the frozen continent pressing down as if guarding its secrets. Every fragment of ice that emerges carries with it the whispers of an ancient Earth, air bubbles trapped since the time of early humans, before civilization even began to dream of conquering the unknown. Then, among the frozen relics, something unexpected appears. A tiny organism, a cluster of cells frozen in time, yet eerily intact. It is not a fossil, not a shadow of something long dead, but something that may yet stir with the right touch of warmth. The thought is unsettling. Has it been merely sleeping, waiting for an age where it might live again? Scientists, bundled in layers of insulated suits, their breath visible even within their protective gear, lean over their microscopes, hands steady despite the biting cold. They know that what they have found might not just be a remnant of the past, but a living link to a time before the rise of complex life. If this microscopic being has survived eons entombed in ice, what else might be buried deeper, beneath layers untouched by sun or sky? As the excavation continues, the unexpected only grows. Buried within the depths, embedded in the ice like forgotten artifacts, lie meteorites. Stones that have traveled through the abyss of space only to rest here, hidden for an eternity. Some bear the unmistakable scars of their violent journey through the atmosphere. Others are pristine, their alien origins locked within the frozen walls. These fragments of the cosmos may hold clues to the building blocks of life itself, chemical signatures from other worlds, organic compounds that whisper of the possibility that life is not exclusive to Earth. Each meteorite pulled from the ice is another puzzle piece, another glimpse into a past far older than this planet, older than human thought itself. And then there are the lakes, the hidden reservoirs of liquid water buried miles beneath the ice, untouched by sunlight for millions of years. The idea alone is staggering. An entire ecosystem, unseen, unknown, and potentially thriving in absolute isolation. Drilling into these buried lakes is no simple task, for the risk is immense. The moment the barrier of ice is breached, modern contaminants could flood into the pristine waters, corrupting something that has remained pure since a time when continents were not yet as they are today. When the first sample is retrieved, it is unlike anything seen before, a substance that has remained locked away from the cycles of life above. Within the dark waters, beneath the crushing weight of the glacier, strange microbial life stirs. Beings that have never known the surface world, never seen the sun, yet continue to exist in a place that should be utterly inhospitable. The thought is humbling. If life can persist in such isolation, sealed off in an environment devoid of light and warmth, then where else might it thrive in the universe? Could similar hidden oceans exist beneath the icy crusts of distant moons, beneath the frozen wastelands of other planets? Standing on the surface, surrounded by the unbroken whiteness stretching to the horizon, the weight of discovery sinks in. The cold is relentless, seeping through even the thickest layers of protection, a constant reminder of how alien this place is, how indifferent it remains to those who dare to unravel its mysteries. Every step taken is one upon an ancient landscape, a place where history is written in ice rather than stone, where time is measured not in years, but in epochs. To dig into Antarctica is to dig into Earth's own forgotten past, a past that whispers of lost worlds, of unseen life, and of secrets buried beneath the frozen silence, waiting for the right hands to unearth them. It is impossible to stand above the unbroken ice and not feel the weight of time pressing down beneath it. Every step, every breath in the cold air is a reminder that beneath the frozen surface, a story waits to be told. Ice is not just a landscape. It is a living archive, a record of everything the Earth has been, and perhaps hints of what it could become. The deeper one digs, the further back in time they go, peeling away the layers of history not written in books or carved in stone, but locked within frozen walls that have stood untouched for millions of years. There is something almost unsettling about it. The idea that as the world above has changed, as empires have risen and fallen, as forests have turned to cities and oceans have shifted their tides, the ice has remained, unyielding, silent, waiting. But ice does not merely hold the past in its frozen grip. It guards it, preserving ancient atmospheres, long-lost ecosystems, and even traces of life that have not been seen since they first disappeared beneath the encroaching cold. It is more than a barrier. It is a vault, holding the breath of creatures that no longer walk the earth, the chemical signatures of cataclysms that reshaped the world, and the fingerprints of climates that came long before human understanding. In some places, the ice is older than entire civilizations, stretching back to a time when humanity itself was nothing more than a fleeting possibility. To drill into it is to reach across that vast gulf of time, to touch something that existed before human hands could ever hold tools, before human voices could shape words. Yet there is something more compelling, something more profound hidden in the ice, something that extends beyond Earth itself. The deeper the excavation, the clearer it becomes that what is buried here is not just a record of our own planet's past, but perhaps a window into the possibilities of life elsewhere. If life has ever taken root beneath the ice of Antarctica, thriving in the dark, in the cold, in the crushing stillness, then it means that life is far more resilient than we ever dared to believe. It means that deep beneath the frozen crusts of distant moons, beneath the endless ice sheets of alien worlds, something may be stirring just as it has here. Every sample taken, every microorganism found locked within the glacial depths is another piece of a larger puzzle, one that stretches beyond this planet and into the unknown. And so, the digging continues. Not just for knowledge, not just for curiosity, but for something deeper. The search for connection, for understanding, for proof that Earth is not alone in its ability to harbor life. With every core of ice extracted, every hidden secret brought to the surface, there is the lingering sense that this is not just about looking into the past, but about glimpsing a possible future. If Antarctica's frozen tombs can hold life, then perhaps somewhere, out in the vastness of space, another world has been keeping its own secrets beneath layers of ice, waiting, just as this one has, for the right hands to uncover them. There is something unsettling about the idea that ice does not simply preserve the past, but keeps it waiting, as if time itself has been placed on pause beneath its frozen grip. What lies hidden within the depths of Antarctica is not just a record of ancient climates or forgotten atmospheres, but the possibility that things long buried may still have the potential to awaken. In recent years, scientists have pulled fragments of history from the ice that are not simply frozen relics, but something far more unnerving. Viruses, microscopic and dormant for tens of thousands of years, locked away in the deep freeze of glaciers and permafrost. These are not mere fossils of disease, but pathogens that, under the right conditions, could stir once more, returning to a world that has long since moved on from the time in which they first emerged. The thought lingers in the minds of those who study them. What else is entombed in the ice, waiting for the warmth of human discovery to rouse it from its long sleep? But the mysteries of Antarctica extend beyond what is frozen within it. Beneath the miles-thick sheets of ice, There are entire lakes, untouched and unseen by the surface world, buried reservoirs of liquid water that have remained in complete isolation for millions of years. These are not just forgotten bodies of water, but self-contained worlds, sealed off from the rest of the planet, holding ecosystems that have never known sunlight, where life, if it exists, has adapted to conditions unlike anything seen elsewhere on Earth. Scientists know that if organisms have managed to endure in these subglacial lakes, then it means life can survive not just in extreme cold, but in a world of perpetual darkness, in an environment shaped by pressure and ice, by mineral-rich waters untouched by surface winds and rains. And if it can happen here, buried beneath the Antarctic ice, then why not on Europa, Jupiter's frozen moon, where a similar ocean lurks beneath an ice shell that has never known the warmth of a sun? The search for life beneath the Antarctic ice is, in many ways, a search for life beyond Earth, a test of how far the boundaries of existence can be pushed, of whether something as fragile as biology can withstand the most unforgiving of environments. But what if Antarctica holds more than just the secrets of biology? There are places in the ice where satellite imagery hints at something beneath, structures buried so deep that their true nature remains unknown. The idea is as old as human curiosity itself, the question of whether an ancient civilization, lost to time, could have once thrived in a land that is now nothing but an endless frozen expanse. It is easy to dismiss such notions as fantasy, yet Antarctica was not always the lifeless tundra it is today. There was a time, millions of years ago, when it was warm, covered in lush forests, home to rivers and thriving ecosystems. If humanity had emerged in an age long forgotten, would their traces now lie beneath the miles of ice, hidden beyond reach? Some believe that buried beneath the glaciers, deep below where any modern eye has seen, there could be remnants. Structures swallowed by time, artifacts encased in the frozen grip of a continent that has rewritten itself over millennia. Each layer of ice removed, each core sample pulled from the depths, is a step closer to answers that have remained locked away for longer than recorded history. Whether what lies beneath is a world of ancient viruses, unseen ecosystems, or the whispers of civilizations lost to time, the truth remains entombed within the ice, waiting for those who are willing to dig deep enough to find it. 1. Ice drilling in Antarctica, the science and challenges. Every time a drill descends into the Antarctic ice, it is more than just a mechanical process. It is an attempt to pull history itself from the depths, to bring to light what has been hidden for millennia. Ice is not just frozen water, but a layered archive, a record of Earth's past carefully preserved in each successive snowfall that compacted over time. Scientists do not dig blindly. They know that trapped within those layers are pockets of ancient air, snapshots of a world that no longer exists, sealed away in microscopic bubbles. To extract an ice core is to hold time in your hands, to analyze the very breath of a planet that has changed in ways no human has ever witnessed firsthand. Each sample is a silent witness to ages of shifting climates, of ice ages and warming periods, of volcanic eruptions that once darkened the skies and altered the course of history without leaving a trace in written records. It is a slow and meticulous process, requiring precision and patience, as every drilled section must be carefully preserved before it is transported, still frozen, to laboratories where it will be examined for the secrets it holds. But drilling into the ice is not as simple as lowering a drill and extracting a core. Antarctica does not give up its past easily, and the deeper the drilling goes, the more the ice resists, pressing in from all sides with a weight that is built over hundreds of thousands of years. Temperatures drop to extremes that can shatter equipment, and winds howl across the frozen landscape, turning even the smallest task into a battle against the elements. The logistics alone are daunting. Teams must transport heavy drilling rigs across terrain that is constantly shifting, set up stations in the middle of nowhere, and work in conditions that push both human endurance and technology to their limits. The deeper they go, the older the ice becomes, and with that comes the risk of contamination. One mistake, one miscalculation, and a sample that has remained untouched for over 1 million years could be altered beyond use. Scientists must operate with an almost surgical level of precision, knowing that each core they retrieve is a fragile thread connecting the present to the distant past. Yet, despite the difficulty, the ice is worth the struggle. The cores pulled from the depths tell stories that cannot be found anywhere else. How carbon dioxide levels have changed over eons, how the planet has responded to natural cycles of warming and cooling, how past volcanic eruptions sent clouds of ash across continents, altering climates long before human civilization rose. In many ways, these samples are not just about understanding the past, but about predicting the future. If the ice can show how the Earth has reacted to massive shifts before, it might help scientists understand what lies ahead as the planet undergoes rapid changes now. Every drilled core is more than just frozen layers. It is a warning, a lesson, a piece of a much larger puzzle that scientists are racing to piece together before it is too late. Extracting the past from ice is a delicate process, and the methods used must be chosen carefully depending on what scientists are searching for beneath the frozen expanse. The ice does not yield easily, and while drilling through it may seem straightforward, every technique has its strengths and limitations. Sometimes, speed is essential, cutting through the ice as quickly as possible to reach a subglacial lake before contamination becomes a concern. Other times, precision is everything, ensuring that each layer of ice remains intact, preserving the microscopic details hidden within. And then there are moments when drilling is not an option at all, when what lies below is too vast, too fragile, or too unknown to disturb directly, requiring scientists to peer through the ice using instruments that do not touch its surface at all. Hot water drilling is often the method of choice when time is critical, when researchers must bore through miles of ice without the patience for mechanical drilling's slow, careful extraction. High-pressure streams of heated water melt through the ice, carving a narrow tunnel that extends deeper and deeper until it reaches its target. It is the method that has allowed scientists to break into hidden subglacial lakes, accessing water that has remained untouched for millions of years. The speed is an advantage, but the cost is precision. Unlike mechanical drilling, this technique does not preserve a core, leaving behind only an empty hole and the knowledge that something lies at the bottom. For those who need more than just access, who seek to extract ice that has held its secrets for millennia, mechanical drilling is the only way forward. The process is slow, painstaking, a method that cuts into the ice with care, lifting out cylindrical cores that preserve the delicate history stored within. Each core must be handled as though it were made of glass, its layers a fragile recording of time itself. A single core can reveal thousands of years of atmospheric history, from the rise and fall of greenhouse gases to the traces of volcanic ash that once darkened the sky. But mechanical drilling is an arduous endeavor, requiring patience and resilience as the drill must be lowered, retrieved, and cleaned repeatedly, inching deeper with every pass. Yet, some mysteries cannot be reached at all, at least not in a way that allows direct extraction. For those, scientists turn to ice-penetrating radar, a technology that transforms the ice itself into a window rather than a barrier. Radar waves are sent through the frozen layers, bouncing back when they encounter something hidden. An ancient riverbed, a mountain range swallowed by glaciers, the possible remains of something human-made buried beneath thousands of years of snowfall. The results are not always clear, often distorted by the very ice they seek to see through, but they offer glimpses of landscapes that no one has ever set eyes on, revealing the unseen depths of a continent that has rewritten itself over millions of years. Each method is a tool in the search for understanding, a different way of reaching into the unknown, driven by the knowledge that Antarctica still holds more secrets than answers. Whether melting through the ice, cutting away at it layer by layer, or sending signals deep into its depths, every approach is an attempt to peel back the frozen curtain that has hidden the past, the present, and perhaps even the unexpected. No matter how advanced the technology or how meticulous the planning, working in Antarctica always carries an element of risk. The ice is unpredictable, and the sheer remoteness of the continent means that even the smallest miscalculation can have enormous consequences. Scientists are not just battling the cold, they are contending with an environment that does not forgive mistakes. The ice shifts, the wind howls, and the unknown waits beneath the surface, sometimes just beyond reach. And there are times when, even after years of preparation, after overcoming countless technical hurdles, a mission still ends in frustration, forcing researchers to retreat, leaving behind unanswered questions that may never be resolved. One of the most infamous moments of scientific defeat came in 2012 when researchers attempting to reach Lake Vostok, one of Antarctica's most mysterious subglacial lakes, had to halt their drilling just as they neared their goal. After decades of planning and effort, they had finally drilled nearly 4 kilometers down, tantalizingly close to breaching the lake's untouched waters. But with that final breakthrough came a grim realization. The drilling fluids used to keep the borehole from freezing over might contaminate the very water they had worked so hard to reach. If they pressed forward, they risked polluting an ecosystem that had been sealed off for millions of years, erasing whatever pristine secrets it might hold. There was no way to undo the potential damage, no second chance to retrieve an uncontaminated sample. The mission, once so full of promise, ended in an agonizing decision to stop, leaving behind an empty borehole and a question mark over what lay below. But sometimes, the danger does not come from what is hidden beneath the ice, but from the ice itself. In 1965, at Bird Station, researchers learned this in the most brutal way possible. The station had been carved into the ice, a network of tunnels and rooms designed to shelter scientists from the relentless Antarctic elements. For a time, it seemed stable, a frozen sanctuary in one of the harshest places on Earth. But ice is not static. It moves, it compresses, and under enough pressure, it will collapse with unstoppable force. Without warning, one of the station's tunnels gave way, the ice crushing equipment beneath it as if it were nothing more than fragile kindling. It was a reminder that Antarctica is not a passive observer in these scientific pursuits. It is an active force, one that does not hesitate to remind those who work there of their vulnerability. These challenges are not isolated incidents. They are part of the reality of working in one of the most extreme environments on the planet. Every expedition carries risk, and every breakthrough is balanced by the possibility of failure. The ice does not give up its secrets easily, and sometimes, despite all the effort, it does not give them up at all. Yet, that is precisely why scientists keep returning, knowing that the answers they seek are not just buried in ice, but locked in time, waiting for the moment when the right hands, the right tools, and the right decisions align to finally bring them into the light. 2. Climate records in ancient ice. The failures and risks of ice drilling do not deter scientists, because beneath the surface, hidden within layers of compressed snow and frozen time, lies one of the most valuable records of Earth's past. Every expedition, every struggle against the cold and the unpredictable nature of the ice is driven by the need to uncover the story trapped inside. The deeper they drill, the further back in time they travel, and in the fragile cylinders of ice extracted from the depths, history is preserved in ways no other material on Earth can offer. Unlike rocks, which can only hint at ancient environments, or written records, which barely scratch the surface of human history, ice holds something far more tangible. Actual pieces of the past, suspended in the frozen bubbles of air that were trapped the moment the snow fell, undisturbed for hundreds of thousands of years. It is a concept that seems almost impossible. A way to reach back nearly 1 million years and directly analyze the air that once filled the lungs of creatures long extinct, the very same atmosphere that shaped the planet in ways still not fully understood. Each core pulled from the ice sheets of Antarctica is a time capsule, an unbroken sequence of seasons, volcanic eruptions, and shifts in climate so gradual that they are invisible to any other form of historical record. Layer after layer, compressed by the weight of centuries, the ice preserves a nearly flawless timeline of Earth's changing environment, holding within it the secrets of ice ages and warm periods, of carbon dioxide levels rising and falling long before humans ever altered the atmosphere. The air bubbles trapped inside these cores are more than just pockets of ancient air. They are direct samples of past atmospheres, a way to measure exactly how much carbon dioxide, methane, and other gases were present at different points in time. No other material allows scientists to study the past with such precision, to see how the world responded to natural changes in climate before industrialization, before the influence of human activity. It is from these ice cores that scientists have discovered the patterns of Earth's glacial cycles, the long rhythms of freezing and thawing that have shaped the planet for nearly 1 million years. They have traced the rise and fall of greenhouse gases, confirming the connection between carbon dioxide levels and global temperatures, revealing how even small shifts in atmospheric composition can trigger massive transformations in climate. But the ice holds more than just air. It preserves traces of ancient environments in the form of dust, volcanic ash, and even microscopic life frozen in time. The layers can show when massive wildfires burned forests to the ground, when meteorites struck the Earth and filled the sky with debris, when great volcanic eruptions darkened the atmosphere and cooled the planet for years. Some cores contain the fingerprints of catastrophic events, sudden shifts in temperature recorded in the thickness and composition of the ice, moments when the world changed in ways that left scars even in Antarctica's frozen heart. Studying these ancient layers is not just about understanding the past. It is about seeing where the future is headed. The patterns revealed in the ice show how the climate has shifted before, how carbon dioxide levels today are unlike anything seen in nearly 1 million years, how the world is now moving into conditions that have not existed since long before human civilization emerged. The warnings written in the ice are clear, but whether humanity listens to them is another question entirely. The ice does not exaggerate, it does not lie. It simply records, patiently preserving the history of Earth, waiting for those who are willing to read it. The ice does not just store the quiet story of slowly shifting climates. It also holds the echoes of catastrophe. Some of the most dramatic events in Earth's history, moments of sudden change that altered the course of civilizations, shaped ecosystems, and left scars on the planet, are still locked within the frozen bubbles trapped deep in Antarctica's ice sheets. Each tiny pocket of air is more than just a relic of the atmosphere. It carries traces of events that, at the time they occurred, may have felt like the world itself was unraveling. When great volcanic eruptions blackened the sky, when temperatures swung wildly in ways that upended entire societies, the ice recorded it all, preserving evidence that still speaks across the ages. One of the most striking discoveries in these ice cores is the undeniable proof of ancient volcanic eruptions that once shook the planet. Trapped within the layers of ice, scientists find microscopic particles of ash, remnants of explosions so powerful that their impact was felt across continents. But the true revelation comes from the chemical fingerprints within the ice itself. The sudden spikes in sulfuric acid levels, the dramatic drops in temperature preserved in the shifting composition of the layers. Some eruptions were so massive that they temporarily rewrote the planet's climate, plunging temperatures, darkening skies, and triggering years of failed harvests and famine. The ice does not just tell us that these eruptions happened. It shows exactly when they occurred, how much they disrupted the atmosphere, and in some cases, how long their effects lingered. But not all shifts in climate were caused by disaster. The ice cores also contain unmistakable proof of past warm periods and sudden cooling phases, revealing that Earth's climate has never been as stable as it seems. Among these records, the evidence of the medieval warm period stands out, a time between roughly 900 and 1300 AD when temperatures were higher than usual in many parts of the world. It was an era when vineyards thrived in places that would later become too cold for grapes, when Norse explorers reached the shores of Greenland and named it for the green pastures they found there. The ice, in its silent way, confirms this warmth, showing elevated levels of certain greenhouse gases and revealing the subtle changes in atmospheric composition that accompanied this period of relative warmth. But warmth does not last forever. Following the medieval warm period came an abrupt shift. The Little Ice Age, a period of cooling that began around the 14th century and persisted into the 19th. The evidence of this cooling is written clearly in the ice cores, with drops in carbon dioxide levels, changes in snowfall patterns, and even traces of volcanic activity that may have amplified the cold. During this time, rivers that had once flowed freely froze solid, glaciers advanced, and winters became harsher and more unpredictable. Crops failed, societies struggled, and in some places, entire ways of life were forced to adapt to the changing world. The ice holds these records without embellishment, without agenda, simply presenting the raw truth of how the planet has changed over time. The story told by these ancient air bubbles is not just a curiosity. It is a reminder of how fragile the balance of climate truly is. If eruptions, natural variations, and subtle shifts in atmospheric gases could shape the world so profoundly in the past, then the rapid changes seen today carry even greater significance. The ice has seen it all before, and it continues to record, preserving the evidence for future generations, if they choose to listen. The ice has always been a witness, holding on to the past with a patience that outlasts everything built or remembered by human hands. Each layer pressed down by time is a chapter in Earth's long and shifting story, and with every core extracted, scientists turn its pages, revealing moments lost to history. It was in 2017 that researchers drilled into the heart of Antarctica and pulled from its depths something astonishing. The oldest ice core ever recovered, a fragment of the world as it existed 7 million years ago. To hold such a thing in hand was to hold air from an era before humans, before even the cycles of ice ages that shaped the planet as we know it. It was an unbroken connection to a time when Earth's climate was on the edge of transformation, when the rhythms of warmth and cold were still forming patterns that would eventually define the rise and fall of entire ecosystems. This ice, buried beneath layers that had been accumulating for millions of years, was more than just frozen water. Trapped inside were air bubbles that carried whispers of an ancient atmosphere, revealing levels of greenhouse gases that existed before the first great glaciations of the Pleistocene. The composition of these gases, carbon dioxide, methane, and other molecules long locked away, offered an unprecedented glimpse into the climate conditions of an Earth untouched by human influence. The numbers etched into this ice told a quiet but profound story. The world had once been on the precipice of major change, and understanding that moment could hold answers for the changes happening now. Extracting this ice was not just a matter of drilling down, reaching in, and pulling it to the surface. The Antarctic depths do not give up their secrets easily. The ice had been buried for eons under crushing pressure, its crystalline structure altered by time, its layers compressed into a history written in delicate stratifications. Even reaching it was a feat of endurance, requiring precision to avoid contamination, patience as the drills carved through the frozen landscape, and faith that what lay below was worth the effort. In the bitter cold, in a place where no life could survive unprotected, scientists stood at the edge of deep time itself, uncovering a piece of the past that had waited in silence. Holding ice that old, analyzing the air sealed within, is as close as one can come to breathing in the air of an Earth that existed before even the cycles of the Ice Age began. It is a reminder that our planet is not static, that it has shifted and changed long before humans could record its movements, and that by reading its frozen archives, we may better understand the forces still shaping it today. The past is not lost. It is buried, waiting, and in places like Antarctica, where time itself seems to stand still, it can be found again. 3. Life trapped in ice, ancient microbes and viruses. Beneath the frozen landscapes of Siberia, where the ground has remained locked in ice for tens of thousands of years, something ancient slumbered, untouched by time. It was buried deep beneath permafrost, a layer of earth so cold and unmoving that it had preserved fragments of a world long gone. In 2014, a team of scientists uncovered something astonishing. An ancient virus, frozen in stasis for 30,000 years, waiting in silence. It had once thrived in an era when woolly mammoths still roamed and early humans fought against the elements to survive. Yet, despite the passage of millennia, despite the changes that had reshaped the planet's surface, this microscopic entity had not perished. It had simply waited. There is something deeply unsettling about the idea that life can endure beyond time's reach, evading decay in a prison of ice. The moment the scientists placed the thawed virus into contact with its host, a species of amoeba, it came back to life as if it had never been buried at all. It was as if time had folded in on itself, as if a whisper from the past had slipped into the present unnoticed. This was not a virus meant for humans, nor was it some long-forgotten plague, but the mere fact that it could awaken, its genetic code still intact, and functioning after so long, raise questions that cut to the core of our understanding of life's persistence. The ice holds secrets that should have vanished with the ages. In the deep freeze of permafrost, not only viruses but bacteria, spores, and other microscopic life forms have been discovered in states of remarkable preservation. Some of them may have been alive when the last ice age was in full force, when humans had yet to carve their first civilizations into the earth. And yet, they remain suspended in time. Their survival is a testament to nature's ability to endure against all odds. But it is also a stark reminder of how little we truly control. What else lies buried, waiting for the warmth of the modern world to stir it awake? These ancient microbes were never meant to coexist with the species and ecosystems of today. Their world is gone, buried under ice sheets and lost in the shifting of the continents. And yet, with the climate warming, permafrost is thawing at an alarming rate. What was once sealed away by nature's own vault is now slowly being exposed, and with it comes the possibility of unknown consequences. Some of these microbes, long dormant, might be harmless, relics of a time when life flourished under different conditions. But others could be far more unpredictable, carrying the potential to interact with modern organisms in ways we cannot yet fully understand. For those who uncovered the virus in 2014, the discovery was both a triumph and a warning. Science had proven that life, even in its smallest forms, could defy extinction in ways we had only theorized. But it also revealed that the past is never truly gone. It lingers, frozen beneath our feet, waiting for the right conditions to return. Whether that is a miracle or a threat depends on what else emerges from the melting ice. But not everything that awakens from the ice remains confined to a laboratory, observed under careful conditions. Sometimes, the past resurfaces on its own, unbidden and uncontrolled. In 2016, deep in the Siberian tundra, something long forgotten stirred beneath the warming permafrost. A reindeer carcass, frozen for decades, perhaps even a century, began to thaw as the summer temperatures rose higher than they had in living memory. Within that decaying body lay something invisible yet deadly. Anthrax spores, perfectly preserved, waiting for the moment when conditions would once again allow them to spread. The first signs of trouble were subtle, almost easy to dismiss. Reindeers started dying in greater numbers than usual, their bodies collapsing onto the landscape in eerie stillness. Then, people began falling ill. Herders and their families, those who lived closest to the land and relied on the reindeer for survival. The sickness spread quickly, and the cause became undeniable. A pathogen from the past had re-entered the modern world, carried not by some unnatural experiment, but by the natural course of a changing climate. Anthrax is not a new disease, nor is it particularly rare, but what made this outbreak different was the source. This was not a fresh contamination. It was a disease from another time, locked away in the frozen earth and released only when the ice that had kept it sealed finally gave way. The spores had remained dormant, unaffected by the passage of time, and once they found their way into warm bodies, they became just as lethal as they had been generations ago. It was a reminder that ice does not only preserve, it can also protect, keeping dangers hidden beneath its surface until the balance shifts. For those who lived through the outbreak, it was more than just a scientific curiosity. It was a disaster that took lives, forced evacuations, and shattered the illusion that the past can always be kept at a distance. Vaccinations helped contain the spread, but the reality was unsettling. This would not be the last time something long buried was set loose. With the Arctic and subarctic regions warming at an unprecedented rate, more permafrost is melting, revealing bodies, animals, and long-forgotten burial sites. Within those remains may lie bacteria and viruses that have not interacted with modern immune systems in centuries, perhaps even longer. The question is no longer whether ancient pathogens can return. It is whether we are prepared for when they do. Some may be relatively harmless, unable to infect the species that now dominate the planet. Others, however, may not be so benign. Nature does not operate with a sense of time the way humans do. To a microbe, 1,000 years is nothing, and given the right conditions, it will simply continue where it left off. Whether we are ready for what comes next remains uncertain. But the ice is melting, and the past is no longer content to remain buried. The past is not the only thing that lingers beneath the ice. While some organisms remain frozen in time, waiting to be revived, others have never stopped living at all. In 2013, scientists drilled through 800 meters of Antarctic ice and reached the isolated waters of Lake Willans, a place hidden from sunlight and the outside world for thousands of years. What they found was something that defied expectations. Life, still thriving in the absolute darkness beneath the glacier, sealed away from everything we know. These microbes were not remnants of the past, not long-dormant relics, but an active, living ecosystem sustained by nothing more than the slow chemistry of water and rock beneath the ice. It is easy to think of glaciers as barren, lifeless places where everything is frozen into stillness, incapable of change. Yet, under the thick sheet of ice that covers Antarctica, entire hidden lakes exist, locked away in isolation for millennia. Scientists had long suspected that something might survive down there, but the discovery of microbes in Lake Willans proved that even in one of the most extreme environments on Earth, life finds a way. These organisms had adapted to a world without sunlight, without fresh nutrients from the surface, surviving instead on the minerals and energy locked in the rock below. To them, the ice above was not a barrier. It was a shield, protecting them from everything that could disturb the delicate balance of their hidden world. For those who first saw the water samples teeming with microbial life, it was more than just a scientific breakthrough. It was a revelation about the resilience of life itself, about the sheer determination of biology to persist in even the most unwelcoming conditions. These microbes had never known the warmth of the sun or the presence of larger organisms, yet they had carved out an existence in a place where nothing should have survived. It raised profound questions about where else life might exist, not just on Earth, but beyond it. If something could endure in the cold, dark depths of an Antarctic subglacial lake, why not beneath the ice-covered oceans of Europa or in the buried water reserves of Mars? But beyond the grander questions of extraterrestrial life, there was something deeply human about this discovery. It was a reminder that Earth is still full of mysteries, that even in an age where satellites map every inch of the surface, there are still places untouched, still secrets waiting to be uncovered. The microbes in Lake Willans had been there all along, indifferent to the passage of time, to the rise and fall of civilizations. To them, nothing had changed. And yet, for us, their discovery meant that our understanding of life had shifted forever. The ice had concealed them for thousands of years, but in the end, it had also preserved them, holding on to the quiet truth that life, in its most persistent forms, never truly disappears. 4. Hidden subglacial lakes, Antarctica's lost worlds. If life could thrive beneath the ice of Lake Willans, then what might exist in the even deeper, more ancient waters of Antarctica's hidden lakes? Some of these subglacial reservoirs have been sealed away not just for thousands of years, but for millions, their isolation stretching so far back in time that they predate humanity itself. Of all these lost worlds, none is more enigmatic than Lake Vostok, a body of water buried beneath nearly 4 kilometers of Antarctic ice, untouched by sunlight for an estimated 15 million years. It is a place so remote, so completely cut off from the surface, that it exists almost as a world unto itself. An ecosystem, if one exists at all, that has never known the sky. For decades, Lake Vostok remained an unseen mystery, its existence theorized long before it was confirmed. Scientists suspected that beneath the crushing weight of the East Antarctic ice sheet, geothermal heat from the Earth's interior kept the lake liquid, preventing it from freezing solid despite the extreme conditions. When radar mapping finally revealed its presence, it became one of the most tantalizing frontiers in the study of life's persistence. If anything had managed to survive in its depths, it would have done so in total darkness, under immense pressure, with no direct connection to the outside world for longer than human civilization has existed. The thought of what might be lurking in Lake Vostok is both thrilling and unsettling. Unlike Lake Willans, which had been briefly exposed to surface influences, Vostok has remained in absolute isolation, its waters unbroken by even the smallest disturbance. If microbial life exists there, It would have adapted to an environment unlike anything we know, living off the faint traces of nutrients that filter through the bedrock, possibly relying on chemical reactions instead of sunlight to sustain itself. If anything more complex than bacteria had somehow endured, it would challenge everything we think we understand about evolution and survival in extreme conditions. Reaching the lake itself has been a slow and cautious process. The risk of contamination is enormous. Introducing modern microbes to a world that has been untouched for millions of years could irrevocably alter whatever fragile ecosystem might exist there. When Russian scientists finally breached the surface of the lake in 2012, the samples they retrieved were inconclusive, with hints of life but nothing definitive. The water, drawn up through a narrow borehole, had been exposed to drilling fluids, leaving lingering questions about whether what they found truly came from the lake itself or was introduced in the process. The mystery remains, buried beneath kilometers of unyielding ice, waiting for a cleaner, more precise exploration. The secrets of Lake Vostok stretch beyond Earth itself. If life can survive there, it strengthens the case for hidden oceans elsewhere in the solar system. Beneath the frozen crust of Europa, beneath the methane seas of Titan, beneath the thick ice of Enceladus. The same forces that keep Vostok liquid could be at work on other worlds, sheltering life in the darkness, preserving it in places where we least expect it. But for now, those answers remain buried. The lake lies undisturbed, its waters holding the weight of 15 million years of solitude, waiting for the day when the ice above is carefully, cautiously, pulled back to reveal what has been hidden for so long. The mystery of Lake Vostok was too great to leave untouched forever, but reaching its ancient waters was never going to be simple. In 2012, after years of effort, Russian scientists finally succeeded in drilling through nearly 4 kilometers of Antarctic ice, breaking into a world that had remained sealed away for 15 million years. It was a moment filled with both excitement and uncertainty. What they had uncovered was unlike anything else on Earth. Water that had never felt the open air, never known the presence of modern life. But the victory was not without risk. The very act of drilling, the process of breaching that pristine environment, carried the danger of irreversible contamination. To penetrate the ice, the team had used kerosene and antifreeze to keep the borehole from freezing shut, a necessary but imperfect method that left lingering doubts. When water from the lake finally surged up through the drill hole, it mixed with the chemicals before freezing again near the surface. The samples they retrieved, though compelling, were not as pure as they had hoped. The potential for life in Lake Vostok was still there, hidden within the depths, but proving it would require an even more delicate approach, one that would not disturb the fragile balance that had existed in that world for millions of years. For the researchers who had spent years pushing toward this goal, it was both an achievement and a challenge. The lake was no longer just a theory. It was real, reachable, and waiting to be explored further. But they now had to contend with the ethical and scientific dilemmas of how to proceed without tainting the very thing they were trying to study. Any microbes that had survived in that extreme environment could have evolved in ways completely alien to modern biology, shaped by pressures, chemical cycles, and isolation that no other ecosystem had experienced. If outside bacteria were introduced, even in trace amounts, they could overwhelm or destroy whatever had managed to endure there for eons. The deeper question was whether humanity had the right to disturb such a place at all. Lake Vostok had remained untouched not just for human history, but for countless ages before it, an ecosystem frozen in time, unshaped by the outside world. It was a natural experiment running for millions of years, a glimpse into a past long before our species existed, and potentially a window into the kind of life that could exist elsewhere in the universe. But just as the ice had preserved it, it had also protected it, shielding it from everything that might disrupt its ancient equilibrium. The moment the drill broke through, that protection was compromised, and the risk of contamination became an unavoidable reality. Further exploration of Lake Vostok would have to be done with more precision, more care, with methods that could ensure the lake's waters remained as pure as they had been before the first drill descended. The discovery had opened a door to a hidden world, but the challenge was now one of restraint, of knowing when to push forward and when to step back, to protect what had remained untouched for so long? The answers still lay beneath the ice, waiting. But whether we could retrieve them without leaving a mark remained the greatest test of all. The challenge of reaching Lake Vostok was not just about uncovering an ancient, untouched world. It was also a test, a rehearsal for something even greater. The same barriers that shielded Antarctica's hidden lakes from contamination are the ones we will face when searching for life beyond Earth. If microbes can survive in the eternal darkness beneath kilometers of ice on our own planet, then the same could be true for the oceans of Europa and Enceladus, two of the most promising places in the solar system where alien life might exist. But reaching them will require the same level of patience, precision, and an understanding of how to explore without disturbing the very things we are trying to study. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both hide vast liquid oceans beneath thick crusts of ice, kept from freezing solid not by sunlight, but by the gravitational forces of their parent planets. Tidal flexing, the constant push and pull from their orbits, generates internal heat, creating conditions where liquid water can persist in the deep. On Earth, wherever there is liquid water, there is life. The question now is whether the same holds true on these distant worlds. But before we send probes to drill through alien ice, we must first prove that we can do it here, in the most remote and hostile environments our own planet has to offer. The methods used to reach Antarctica's buried lakes are a glimpse into the future of space exploration. The precautions taken to avoid contaminating Lake Vostok mirror the concerns scientists have about drilling into Europa's ice, where even the slightest mistake could introduce Earth microbes into an untouched extraterrestrial ecosystem. Learning how to melt through thick ice sheets without disturbing what lies beneath, how to retrieve pristine samples without altering their chemistry, and how to operate delicate machinery in extreme conditions. All of these are problems that must be solved before humanity can reach the hidden oceans of the outer solar system. Yet the connection runs deeper than technology alone. The discovery of microbial life in subglacial lakes, places once thought too extreme to support biology, has reshaped our understanding of where life can persist. It has forced us to reconsider what it means for a world to be habitable. It is no longer just about the presence of liquid water, but about how life can adapt, how it can find energy in the unlikeliest of places. The ecosystems beneath Antarctica's ice survive without sunlight, without fresh nutrients from the surface, relying instead on the slow chemical processes in rock and water. If life has found a way to endure there, then why not in the buried seas of Europa, where hydrothermal vents may churn at the bottom of a vast, unseen ocean? Or in the icy plumes of Enceladus, where water erupts into space, carrying secrets from the depths below? Each step we take toward understanding our own planet's hidden frontiers is a step toward unraveling the mysteries of the cosmos. Drilling into Antarctica's frozen lakes is more than just an exploration of Earth's past. It is a glimpse into other worlds, a way to prepare for the moment when we finally send a probe through the ice of an alien moon, searching for something that has waited in the dark for far longer than we have dared to look. The answers may still be hidden beneath layers of ice, both here and beyond our planet. But for the first time in human history, we are learning how to reach them. 5. Antarctic meteorites, space rocks preserved in ice. As scientists search for answers buried beneath Antarctica's ice, they also look upward, not to the sky, but to the very ground beneath their feet, where pieces of the universe itself have been waiting to be found. Antarctica, despite its remoteness, holds more meteorites than almost anywhere else on Earth. It is a place where space rocks, having traveled across the solar system, find their final resting place, preserved in the ice for thousands, sometimes even millions of years. Unlike other landscapes, where meteorites can be lost in dense forests, eroded by rain, or buried beneath shifting soil, Antarctica offers a vast, frozen archive where these fragments of other worlds remain untouched, locked in time. The process that makes Antarctica such a rich meteorite hunting ground is as fascinating as the discoveries themselves. When a meteorite falls onto the ice, it becomes embedded within the slow-moving glaciers, gradually being carried through the relentless flow of ice sheets. Over centuries, the forces of nature push these rocks toward concentrated areas, where the ice, blocked by mountains or ridges, is stripped away by powerful winds. This leaves behind a natural collection of meteorites, resting on the surface like scattered relics from the depths of space. Unlike in deserts, where meteorites blend into the landscape, or in populated regions, where they are rare and difficult to find, Antarctica presents them in stark contrast against the endless white, waiting for someone to pick them up and decipher their story. Each meteorite found in the Antarctic ice holds a story older than anything on Earth. Some are fragments of asteroids that have wandered the solar system since its formation, remnants of ancient collisions that shaped the planets. Others have more extraordinary origins. Pieces of the moon, blasted away by impacts long ago, or even fragments from Mars, carrying clues about its past, possibly even hints of ancient life. These rocks are time capsules, untouched by the weathering forces that would degrade them elsewhere, allowing scientists to study their pristine compositions, revealing secrets about the early solar system, planetary formation, and the chemistry of distant worlds. For those who walk across the Antarctic ice in search of these treasures, each discovery is more than just a scientific achievement. It is an encounter with the unknown, a moment where a rock that has traveled millions of kilometers through space is lifted from the ice, its journey from the cosmos to this frozen wasteland now complete. These meteorites are among the most tangible connections humanity has to the universe beyond Earth, fragments of a much larger story that we are only beginning to understand. In this place of ice and isolation, where life is scarce and silence stretches for miles, the past and the distant future meet, locked within stones that have fallen from the sky, waiting for human hands to uncover their secrets. Among the countless meteorites resting on the Antarctic ice, there is one that stands apart, not just for its origin, but for the controversy it ignited. In 1984, a team of researchers scouring the frozen expanse of Allen Hills stumbled upon an unremarkable-looking rock, one that had been waiting in the ice for an untold stretch of time. At first glance, it seemed like any other meteorite, a fragment of something far older than the Earth itself. But this particular rock, later named Allen Hills 84001, was not just any spaceborne traveler. It had come from Mars, a relic of a violent past where impacts had torn pieces from the Martian surface and flung them into the void, where they drifted for millions of years before falling to Earth. And inside this ancient rock, some scientists believed, was evidence of something extraordinary: life. The meteorite's story took a dramatic turn in 1996 when a group of researchers, led by NASA, announced that they had found structures within its mineral layers that bore a striking resemblance to fossilized bacteria. The tiny formations, no wider than a fraction of a human hair, looked eerily similar to microbial life on Earth, leading to a question that shook the scientific community. Had we just discovered the first evidence of extraterrestrial life, not on some distant world, but locked inside a Martian rock that had landed on our own planet? The implications were staggering. If life had once existed on Mars, even in the most primitive microbial form, then the universe was no longer a lonely place. It meant that, at least once before, biology had emerged on another world, and if it happened there, then perhaps it was happening elsewhere, in ways we had yet to understand. But science is rarely straightforward, and neither was the fate of Allen Hills 84001. Almost as soon as the claims were made, they were met with skepticism. Other researchers argued that the structures inside the meteorite could have been formed through natural chemical processes rather than biological ones. Some pointed to the lack of definitive organic molecules, while others suggested that contamination from Earth might have played a role in the findings. Over the years, studies have gone back and forth, dissecting every microscopic feature, debating whether this rock truly carries whispers of ancient Martian life or if the shapes within it are nothing more than an illusion, a trick played by geology and chemistry. Regardless of the final verdict, the meteorite changed the course of planetary science forever. It pushed the search for life beyond Earth into the mainstream, fueling new missions, new questions, and an insatiable curiosity about what might lie beneath the surface of Mars or hidden within the oceans of icy moons. It became a symbol, not just of scientific discovery, but of the relentless human need to know if we are alone. Whether Allen Hill's 84001 holds proof of Martian life or not, it remains one of the most intriguing artifacts ever found, a silent messenger from a planet that has long captured our imagination. And somewhere in the vast ice fields of Antarctica, more fragments of Mars, or perhaps even more astonishing discoveries, may still be waiting, buried just beneath the surface, untouched and unnoticed until the day they are finally uncovered. As meteorites continue to be uncovered from the frozen surface of Antarctica, some researchers have turned their attention to what might lie beneath the ice itself. The vast, untouched wilderness of the continent has preserved not only fragments of space, but perhaps even the scars of cosmic collisions. Beneath kilometers of ice, hidden from view for millions of years, some scientists believe there may be a massive impact crater, a remnant of an ancient catastrophe that shaped the very history of life on Earth. If such a crater exists, it would mean that long before the ice claimed this land, something truly enormous struck with enough force to leave a mark that still lingers beneath the surface. One of the most intriguing possibilities comes from satellite data and radar imaging, which suggests that a circular structure might be buried beneath the East Antarctic ice sheet, near Wilkes Land. Some estimates propose that this hidden formation could be over 500 kilometers wide, far larger than the impact crater left by the asteroid that wiped out the dinosaurs. If it is indeed an impact site, it would mean that Earth was struck by a celestial body so massive that it could have triggered global devastation, altering the course of evolution in ways we may never fully comprehend. Some have even speculated that this event, if it occurred around 250 million years ago, might be linked to the Permian-Triassic extinction, the deadliest known mass extinction, which wiped out around 90% of marine species and 70% of land species. But proving the existence of such a crater is no simple task. The thick Antarctic ice acts as both a shield and a veil, preserving whatever is beneath it, but also making direct investigation nearly impossible. Unlike impact craters on the surface of other planets or on ice-free regions of Earth, which can be studied through exposed rock layers, the frozen depths of Antarctica make traditional geological analysis nearly unattainable. Drilling deep enough to confirm whether a crater exists would be a monumental challenge, requiring not just cutting-edge technology, but also the endurance to work in one of the harshest environments on the planet. Still, the idea of an ancient impact hidden beneath Antarctica continues to fuel speculation. If confirmed, it would add a new chapter to Earth's violent past, another reminder that the cosmos is not a silent place, but an unpredictable and sometimes destructive force. It would reinforce the reality that asteroid impacts have played a role in shaping life itself, acting as both destroyers and catalysts for change. And if such an impact once reshaped the world, leaving its traces entombed beneath ice that has stood for millennia, then Antarctica holds more than just meteorites. It holds the echoes of a collision that may have rewritten the story of life long before anyone could witness it. 6. Fossils and prehistoric life in ice. If ice has the power to conceal the scars of an ancient cosmic impact, then it also holds within it something equally astonishing: fragments of life from a world long gone. While the frozen expanse of Antarctica may seem like an unbroken wasteland, locked in silence and isolation, it is, in reality, a vast and unintentional archive, preserving echoes of creatures and ecosystems that existed before humans ever set foot on this planet. Over time, ice has become a natural time capsule, capable of holding onto the past with an almost impossible precision. Unlike bones buried in shifting earth or fossils compressed over millions of years, frozen remains can capture a moment in time, a body caught in the process of life, and then preserved as if waiting for someone to uncover it. In the depths of the permafrost, entire mammoths have been found, their fur still intact, their flesh so well preserved that scientists have been able to analyze their DNA and study the food still trapped in their stomachs. These creatures once roamed a very different world, one where ice did not imprison the land but shaped it, where early humans may have gazed upon them, unaware that they would one day become nothing more than relics of a vanished age. And it is not just mammoths. In the frozen regions of the southern hemisphere, Antarctica has yielded the remains of giant penguins. Massive seabirds that once stood nearly as tall as a human, thriving in an ancient climate that was far warmer than it is today. Their fossils, preserved in layers of ice and rock, tell a story of an environment that was not always barren but once teemed with life, a land that supported creatures that would now seem utterly out of place in the modern world. Even older than these creatures are the remnants of ancient plants, preserved in ice and sediment, revealing that Antarctica was once home to lush forests, rivers, and entire ecosystems that could not exist in its present-day form. Leaves, pollen, and even pieces of wood frozen in time provide evidence that this land, now so hostile and unyielding, was once a place where life thrived in abundance. These discoveries paint a picture of a world in flux, a reminder that no landscape is permanent, that ice and warmth trade places over eons, reshaping continents and erasing entire ways of life. And yet, as much as ice preserves, it also destroys. The slow movement of glaciers grinds ancient remains to dust, and the thawing of permafrost threatens to undo what has been kept intact for millennia. The very thing that protected these ancient beings could just as easily erase them forever. Scientists race against time to recover what they can, knowing that each discovery is not just a piece of the past, but a window into a world that existed long before our own. And with each fossil, each frozen creature, each leaf trapped in ice, we are reminded that the Earth is not a static place, but one that has undergone transformations beyond anything we can fully grasp, and that even in the coldest, most desolate places, history is waiting beneath the surface, waiting to be found. The idea of ice as a time capsule becomes even more striking when it doesn't just preserve fragments of past climates or microscopic life, but entire lost landscapes. Forests that once thrived in places now buried beneath miles of frozen silence. Creatures that walked beneath a sun that shone on an Earth unrecognizably different from the one we know. The thought alone is enough to make the ice seem less like an unforgiving wasteland and more like a delicate veil drawn over an ancient world, waiting for the right moment to reveal itself again. In Antarctica, beneath layers of ice that have hidden them for millions of years, scientists have uncovered fossilized trees. Traces of forests that once flourished in a place now known only for its barren, frozen desolation. These weren't just scattered bits of wood or isolated impressions in rock. They were evidence of entire ecosystems, trees that grew tall and strong in a time when Antarctica was not the icy expanse we see today, but a land of flowing rivers, lush plant life, and thriving creatures. Some of these forests date back over 280 million years, from a time before even the age of dinosaurs, when the continent was still part of the ancient supercontinent Gondwana. Leaves, bark, and even the structures of the trees themselves were preserved, offering a glimpse into an Earth that experienced no winter, a world where life adapted to the extremes of light and darkness near the poles long before humans ever imagined setting foot there. Far to the north, another frozen discovery told a different kind of story, one not of trees, but of a creature that had walked the Earth long before ice claimed its resting place. In 2017, scientists unearthed the well-preserved remains of a dinosaur from Arctic permafrost, a reminder that what is now a cold, inhospitable land was once teeming with life. The Arctic, like Antarctica, was not always locked in ice. Millions of years ago, it was a region of forests, lakes, and creatures adapted to a world where the sun never set for half the year and then vanished for months of darkness. The dinosaur's discovery was a rare gift. Its bones frozen in time, its presence an echo of an era long past. The very fact that it was so well-preserved hints at the power of ice, not just as a force of destruction, but as a protector, holding onto the past with an unrelenting grip, refusing to let it disappear completely. These discoveries shift the way we see the frozen places of Earth. They are not just wastelands, not just harsh, empty expanses of ice and snow. They are places of transformation, places where the past is still waiting beneath the surface, where forests and creatures long thought lost still leave their mark in stone and frozen remains. With every new discovery, the line between past and present blurs just a little more, and we are reminded that ice is not an end. It is a doorway, one that leads to a world we are only beginning to rediscover. 7. Could there be lost civilizations under ice? If the notion of lost worlds buried beneath the waves captures the imagination, then the idea of entire civilizations entombed beneath ice is something even more haunting. Antarctica, a continent now defined by its desolation, was not always the frozen wasteland it is today. Geological records whisper of a past that seems almost impossible to reconcile with its present state. Millions of years ago, it was a land of flowing rivers, vast forests, and possibly conditions capable of supporting life far beyond the simple organisms that now cling to existence at its edges. But the question lingers: could it have been home to something more? A civilization swallowed not by the sea, but by ice itself? Antarctica's past is written in layers of rock buried beneath the ice sheets, and the story they tell is one of dramatic shifts. Around 90 million years ago, during the Cretaceous period, this land was a warm, thriving environment teeming with life. Fossilized remnants of ancient trees have been found, along with evidence that a temperate rainforest once covered what is now an endless expanse of white. But this was a time before humans, long before anything resembling civilization had even taken its first steps. The real mystery lies in a much later era, in the time before Antarctica was fully swallowed by the ice, when early humans were already spreading across the world. Ice cores and geological surveys suggest that as recently as 12,000 years ago, the continent was not as hostile as it is today. If parts of it were free from ice, could they have been habitable? And if so, did anyone ever live there? The idea that an ancient civilization might have thrived on Antarctica before the ice took hold is one that exists in the margins between history and speculation. Some point to ancient maps as evidence. Most famously, the Piri Reis map, a 16th century Ottoman map that appears to depict the coastline of Antarctica without ice. How could cartographers from centuries ago have known what the land beneath the ice looked like? The official answer is that such maps were likely based on earlier, possibly lost charts made by civilizations with advanced maritime knowledge, though this doesn't necessarily imply they knew Antarctica as a livable world. And yet, the idea persists. If a civilization had existed there, what would have happened to it? Would it have succumbed to the encroaching ice, forced to flee as the world turned colder, their ruins crushed beneath glaciers over thousands of years? Or is it possible that any traces of them still remain, locked away beneath miles of ice, waiting to be uncovered? Modern science has begun to peer beneath Antarctica's frozen shell with radar mapping, revealing buried mountains, valleys, and even ancient river systems. Some have even proposed the existence of vast subglacial lakes and hidden caverns that could, in theory, have provided refuge for life long after the surface was uninhabitable. But these discoveries, as fascinating as they are, have yet to reveal anything that suggests human presence in the deep past. The ice is an impenetrable vault, one that has swallowed time itself, erasing everything that might have once stood on the surface. And yet, there is something unsettling about the idea that we may never truly know. If anything remains beneath that frozen world, it has been hidden away more effectively than any ruin buried beneath the sands of the desert or the depths of the ocean. Perhaps that is what makes the idea so compelling. Antarctica is the last true frontier of the unknown, a place where myths can still breathe because the ice guards its secrets so well. If there was ever a civilization there, its fate would have been a slow, inevitable burial, its structures crushed beneath the weight of ice sheets growing ever thicker, its people forced to leave behind the land they called home as it turned into an inhospitable abyss of cold and darkness. If ruins exist, they would not be like those found elsewhere in the world. No towering stone remnants standing defiantly against time, no half-buried temples waiting to be uncovered, but something more final, more absolute. Ice does not preserve in the way the desert sands do. It consumes. It destroys. And yet, the question remains, what if? What if beneath the continent's frozen heart, something still lingers, waiting for a moment when the ice retreats once more? If the ice of Antarctica is a vault, then satellite images have become the prying eyes trying to peer through the cracks, searching for something, anything, that might challenge what we think we know about the frozen continent. In recent years, a growing number of anomalous images have surfaced, fueling speculation that something unnatural lies hidden beneath the vast sheets of ice. Some claim these images reveal the unmistakable outlines of structures, geometric formations too precise to be the work of nature, suggesting that whatever once stood there has been entombed for thousands of years, preserved beneath the unrelenting weight of time and cold. It's easy to dismiss such claims as wishful thinking, a human tendency to impose patterns onto chaos, to see meaning where none exists. But there are images that resist easy explanation. Some show what appear to be linear formations, symmetrical arrangements of ridges and depressions that, at first glance, look strikingly like roads, walls, or even the foundations of long-lost buildings. Others reveal vast rectangular anomalies, their edges sharply defined against the surrounding landscape, as if something artificial had been swallowed by ice and partially exposed again by shifting glaciers. Could these truly be the remnants of something ancient, or are they merely the scars of the ever-moving, ever-changing ice sheets carving strange shapes into the land? The mystery deepens when considering the limitations of satellite imaging itself. Antarctica is not an easy place to study from above. Snowstorms, shifting ice, and the sheer remoteness of the landscape make it difficult to interpret what is really being seen. A shadow cast at the right angle, a buried ridge revealed by melting, or the natural fracturing of ice can create illusions that play tricks on the mind, making the terrain appear far more structured than it actually is. But even among scientists, there are moments when something defies easy classification. In 2012, a strange formation was spotted near the Shackleton Range, an area that had long been buried beneath thick ice. The images showed what appeared to be a series of massive, evenly spaced rectangular depressions, almost as if a set of ruins had begun to emerge from their frozen tomb. Officials dismissed the discovery as nothing more than natural geological processes, yet the idea took on a life of its own, drawing comparisons to other inexplicable formations found across the icy expanse. One of the most persistent theories is that these so-called structures are remnants of an ancient civilization, buried long before recorded history began. If Antarctica was once habitable, then the idea that early humans, or even a lost culture, might have once lived there is not entirely impossible. But the problem lies in proof. No artifacts, no tools, no remnants of human activity have been found beneath the ice, only images that raise more questions than answers. There are those who suggest that any evidence would be too deep to detect, crushed and buried over millennia, hidden beneath layers of ice too thick to penetrate without massive excavation efforts. And there are others who believe that such ruins have already been found, only to be deliberately concealed, their existence deemed too disruptive to our understanding of history. Theories range from the plausible to the absurd. Some suggest that ancient builders, perhaps even seafarers from a forgotten civilization, once inhabited the continent before the ice swallowed their world. Others take the mystery even further, speculating that the structures are not human at all, but remnants of something far older, something that predates known history entirely. But the reality is more elusive. For now, these images remain just that, fragments of uncertainty, frozen in time, inviting speculation but refusing to yield definitive answers. Perhaps the truth is still waiting beneath the ice, waiting for the day when the continent, now locked in an icy grip, begins to thaw, revealing whatever it has kept hidden for so long. Speculation thrives where certainty fades, and nowhere is this more evident than in the debate over what might lie beneath Antarctica's ice. While satellite images stir the imagination, the deeper question lingers. Could an ancient civilization have once flourished on the continent before it became the frozen wasteland we know today? Science and speculation collide here, one side grounded in geological evidence, the other in the tantalizing gaps of history where possibilities, however improbable, still breathe. To even entertain the idea, one must first understand just how dramatically Antarctica has changed over time. Antarctica was not always a place of ice and desolation. Geological records tell a story of a continent that, millions of years ago, was covered in lush forests, inhabited by a variety of prehistoric creatures. Fossilized plants, remnants of ancient river systems, and even the preserved remains of animals similar to marsupials have all been found beneath the ice. This much is undeniable. There was once life here, and not just microbial life, but an entire ecosystem that thrived in a climate vastly different from what we see today. However, this was long before humans emerged, long before anything resembling civilization existed anywhere on Earth. The last time Antarctica was truly free from ice was around 34 million years ago, when a shifting global climate sealed its fate, trapping it in an ever-deepening cold that eventually turned it into the most inhospitable place on the planet. If civilization had ever existed there, it would have had to flourish before this transformation, in an era when humans did not yet walk the Earth. This is where the scientific argument closes the door, where evidence dictates that no human civilization could have possibly existed in Antarctica's warm past. And yet, the idea refuses to die, not because science is uncertain, but because mystery has always held more power over the human mind than certainty. The conspiracy theories that surround Antarctica often lean on the notion that history is incomplete, that our understanding of human civilization is flawed or deliberately obscured. Some claim that an advanced civilization predating recorded history could have risen in Antarctica and been wiped out, its ruins buried beneath millions of years of ice. Others propose that humanity's past extends far beyond what mainstream archaeology acknowledges, that an unknown people may have inhabited the continent before a great catastrophe forced them into extinction. These ideas, though lacking in evidence, persist because they play upon the natural human instinct to question the unknown. The debate is not one of equal footing. Science, armed with geology, ice core samples, and radiometric dating, places a definitive limit on when and where human civilizations could have existed. But conspiracy thrives in the shadows cast by the gaps in knowledge, the places where evidence is scarce and imagination fills the void. Could ruins exist beneath the ice? It is not impossible for undiscovered geological formations to resemble structures, for natural phenomena to be mistaken for something artificial. But if a civilization had ever truly lived there, if something human had ever carved out a world beneath the Antarctic sun before the ice consumed everything, it would have been so long ago that all traces of it would now be dust, buried so deeply that even the most advanced technologies of today would struggle to find any proof. The ice is not just a barrier. It is an eraser, wiping clean anything that might have once stood, ensuring that if something was there, all that remains now is silence. 8. Geological mysteries beneath Antarctic ice. The ice erases, but it also conceals. If a civilization had once stood upon the frozen expanse of Antarctica, time and glacial weight would have reduced it to nothing. Yet, beneath that same ice, hidden away from the world for millions of years, there are landscapes that defy expectation. Mountains, valleys, entire river systems buried under miles of ice, untouched by human eyes, but slowly revealing themselves through the penetrating gaze of radar technology. Among the most astonishing discoveries is a mountain range that should not exist, a hidden world frozen in time, the Gamburtsev Mountains. Buried beneath more than 2 miles of solid ice, these mountains stretch across an area the size of the Alps, their peaks sharp, their ridges and valleys eerily well-preserved despite being locked away for what scientists believe is at least 34 million years. It is difficult to fathom. An entire mountain range, unseen, its presence only detected through echoes of radio waves bouncing back from deep within the frozen continent. When first discovered in the 1950s, their existence raised immediate questions. How could a range so massive have formed? And why had it remained so perfectly hidden? The deeper scientists delved into the mystery, the more baffling it became. Most mountain ranges are formed by the collision of tectonic plates, the slow, grinding force of the Earth reshaping itself over millennia. But the Gamburtsev Mountains showed no clear signs of such a collision, no evidence of the violent upheaval that gives birth to peaks of such magnitude. They appeared to have formed through a process far less understood, one that defied the typical patterns of mountain building. What makes them even more unusual is their state of preservation. Over millions of years, mountains are usually worn down by erosion, carved by wind and rain, reduced to rolling hills as time wears them away. But these mountains have been locked in ice for so long that they remain almost pristine, a snapshot of a world that vanished long before the first humans even existed. The ice, though it crushes and obliterates, has also protected them, sealing them away from the forces that would have long since reduced them to ruins. It is as if they exist outside of time, a hidden relic of a past Earth that no one was ever meant to see. There is something unsettling about the idea that such a massive range could remain unknown for so long, that entire landscapes can exist beneath our feet without our knowledge. What else might be buried beneath the ice, waiting to be uncovered? If mountains can lie hidden for millions of years, what other secrets does Antarctica hold within its frozen depths? The continent is a place where the impossible has already been proven real, where the known world ends and a deeper, stranger reality begins. The Gamburtsev Mountains are just one part of that mystery, a buried monument to forces we do not fully understand, a reminder that even in an age of satellite imaging and deep-sea exploration, there are still places on this planet that remain untouched, unseen, and waiting to be discovered. If an entire mountain range could remain hidden beneath Antarctica's ice for millions of years, then it is no surprise that even stranger discoveries continue to emerge from the depths. But some are more unsettling than others. In 2018, scientists using advanced ice-penetrating radar detected something unexpected: an enormous underground cavity, a void nearly the size of Manhattan, lurking beneath the Thwaites Glacier. It was not a small pocket of air trapped within the ice, but a vast, yawning space where something had carved away over 14 billion tons of ice. Its presence was not just an anomaly. It was a sign of something happening deep within Antarctica, something that defied easy explanation. Glaciers move, shift, and break apart, but a cavity of this magnitude was unlike anything seen before. It raised immediate concerns. Was this a sign of rapid melting? A hidden chamber where warm ocean water was seeping beneath the ice, eating away at it from below? Or was there something else at play, something deeper beneath the surface that had yet to be understood? The Thwaites Glacier, already known as one of the most unstable in Antarctica, became even more of an enigma. The cavity suggested that melting was occurring far faster than previously thought, that the ice sheet was thinning from the inside out. But then came the larger question: the origin of the cavity itself. Had it always been there, a remnant of some ancient geological event? Or was it something new, something forming right now beneath the frozen landscape? The discovery fueled speculation beyond just the scientific implications. Some theorized that such a massive hollow space could be more than just a result of melting. It could be an entrance to something deeper, a natural chamber that had remained untouched for millennia. Others saw it as another piece of Antarctica's long-standing mystery, another reminder that beneath the ice, an entire hidden world could exist, one we barely understand. But the real fear was more immediate. If these cavities were forming faster than expected, then Antarctica's glaciers, already some of the most fragile and critical ice masses on the planet, were in far greater danger than previously believed. The Thwaites Glacier alone holds enough ice to raise global sea levels by more than 2 feet if it collapses completely, and the existence of such an enormous cavity beneath it suggested that collapse was happening faster than anyone had predicted. The discovery in 2018 was not just another anomaly buried beneath the ice. It was a warning. Antarctica, once thought to be frozen in time, is not as stable as it seems. Beneath its surface, things are shifting, changing, and in some cases, vanishing entirely. Whether the cavity is simply a result of natural glacial movement or evidence of something more complex remains an open question, but one thing is certain. The ice is not as solid as we once believed, and the deeper we look, the more we realize how much of Antarctica's story is still waiting to be uncovered. 9. Permafrost versus deep ice sheets. The ice hides, the ice reveals. It erases mountains but preserves bodies, swallows landscapes but entombs the past in near-perfect detail. The same frozen world that conceals ancient cavities beneath glaciers and buries entire mountain ranges can also act as a vault, locking away remnants of life that existed long before modern civilization. But not all ice preserves in the same way. Deep Antarctic ice sheets crush and compress, consuming whatever is trapped within their relentless descent, grinding time itself into oblivion. Permafrost, however, is different. It does not destroy, it holds. Permafrost is not just frozen Earth, it is a time capsule. Unlike the shifting, ever-moving glaciers of Antarctica, permafrost remains locked in place, its layers stable enough to cradle what was once living, keeping it intact for tens of thousands of years. It is within these frozen tombs that scientists have found something astonishing. Fragments of humanity's ancient past, preserved so well that genetic material can still be extracted. Neanderthal bones, frozen in the icy grip of permafrost, have yielded DNA that offers glimpses into a world long vanished, a time when humans were not alone in their existence. The frozen remains of mammoths, wolves, and even plants that once grew in Pleistocene landscapes have also been uncovered, their tissues so well preserved that they appear as if they were only recently buried. Unlike fossils, which are mere imprints of the past, these frozen bodies are something else entirely. Their cells, though long dead, are still tangible, still filled with information, as if time itself had been put on pause. The discovery of Neanderthal DNA within these frozen remains has been nothing short of extraordinary, allowing scientists to reconstruct their genetic lineage, trace their migration patterns, and even understand the ways in which they interbred with early Homo sapiens. The ice does not just preserve bodies. It preserves stories, echoes of lives that would have otherwise been lost to history. But there is something unsettling about what permafrost is beginning to reveal. As the world warms, the ice that once protected these ancient remains is now thawing. What was once safely locked away is emerging, not just bones and genetic traces, but also the unknown. Viruses and bacteria that have been dormant for tens of thousands of years, preserved in the permafrost like microscopic ghosts of a forgotten age. Some of these pathogens, long buried, may be harmless relics, but others could be something else entirely, something that modern immune systems have never encountered before. The difference between permafrost and deep ice sheets is more than just structure. It is a battle between preservation and destruction. Permafrost holds onto the past, keeping it frozen in time, while the deep ice of Antarctica grinds history into obscurity, crushing, compacting, erasing all but the most resilient remnants. And yet, even in the heart of Antarctica, ancient life may still linger in ways we do not yet fully understand. Beneath the deep ice sheets, in isolated subglacial lakes that have been sealed off from the surface for millions of years, unknown microorganisms persist, surviving in total darkness, in an ecosystem completely alien to anything else on Earth. What permafrost has revealed about the past, these ice-covered lakes may one day reveal about life's endurance in the most extreme conditions. The ice, whether preserving or obliterating, remains a keeper of secrets. Some of them are emerging now, thawing from the permafrost, while others remain locked beneath miles of Antarctic ice, waiting for a future when we are finally able to reach them. The question is whether we are prepared for what they will reveal. The ice preserves more than bones. It does more than lock away fragments of lost civilizations or the genetic traces of ancient humans. Sometimes, it does something even stranger. It keeps life itself in a state of waiting. For tens of thousands of years, permafrost has held the frozen remains of mammoths, wolves, and Neanderthals, their tissues preserved so perfectly that their DNA can still be studied. But what happens when something frozen for thousands of years does not simply remain intact, but wakes up? In 2021, scientists made a discovery that defied the natural order of life and death. A microscopic organism, a tiny, nearly indestructible rotifer, was pulled from Siberian permafrost, where it had been entombed for 24,000 years. And when thawed, it did something remarkable. It came back to life. Rotifers are some of the smallest animals on Earth, almost too tiny to see, yet they have an extraordinary ability to survive the impossible. They can endure extreme radiation, crushing pressure, and complete desiccation, entering a state of suspended animation that allows them to exist in conditions that should destroy all living things. But this was different. This was not merely survival in harsh conditions. This was life that had been frozen for longer than human civilization has existed, yet, upon thawing, resumed as if nothing had happened. The rotifer did not just twitch or show signs of molecular activity. It moved, ate, and even began to reproduce. The implications of this discovery were staggering. If such a simple creature could withstand 24,000 years in permafrost and still live, what else might be waiting beneath the ice? Could other microscopic organisms, frozen for even longer, be capable of revival? The realization that life can endure in a frozen state for such vast periods raises questions that stretch far beyond the boundaries of Earth. If rotifers can survive being locked away in ice for millennia, could similar organisms exist on frozen worlds elsewhere in the solar system? Could life be hiding beneath the icy crust of Europa or Enceladus, waiting to be awakened by the right conditions? But there was also an unsettling aspect to this discovery. If microscopic animals could return from the deep past, what else could be lurking in permafrost, waiting to thaw? Scientists have already uncovered ancient viruses and bacteria in melting ice, some of which have remained dormant for tens of thousands of years. What if, like the rotifer, these organisms are not simply frozen remnants of the past, but something capable of reawakening in the present? The ice, once thought to be an impenetrable vault of history, is turning into something else, a door opening to a past that is not entirely dead. This discovery was a glimpse into the resilience of life, a reminder that the frozen world is not as lifeless as it seems. The permafrost does not just preserve memories of the past. It holds life in suspension, waiting for a moment, a shift in temperature, an opportunity to begin again. And as the world warms, as the ice retreats, more than just ancient bones and lost landscapes may emerge from its depths. Life, long thought to be extinct, may simply be waiting for its chance to return. If permafrost is a vault preserving the past in a delicate state of suspension, then the deep ice sheets of Antarctica are something else entirely. A crushing, unyielding mass that seals away whatever lies beneath, untouched for millions of years. Where permafrost clings to fragments of lost worlds, preserving them just enough to be recognized, the ice sheets bury their secrets so completely that even time itself seems incapable of reaching them. There is no slow decay, no gradual erosion, just an endless weight of frozen silence, a world beneath the surface that has remained hidden since long before humans walked the Earth. Unlike permafrost, which holds remnants of life close to the surface, the ice sheets of Antarctica descend for miles, pressing downward with a force so immense that whatever exists below them is not merely frozen. It is entombed. The oldest layers of ice stretch back as far as 1.5 million years, capturing the breath of ancient atmospheres in tiny bubbles, holding traces of climates that no human has ever known. But beneath even those depths, locked away beneath the thickest glaciers, there are places that have been cut off from the surface for far longer. There are valleys and mountain ranges hidden beneath the ice, entire landscapes preserved not in frost, but in darkness, buried under miles of pressure where no light has ever reached. And in some of the deepest, most isolated pockets, there is something even stranger: liquid water. Beneath the crushing weight of the Antarctic ice, under conditions where nothing should exist, scientists have discovered vast subglacial lakes, bodies of water that have remained sealed off for millions of years. These lakes, like Lake Vostok, Lake Mercer, and Lake Whillans, are not frozen despite the unimaginable cold above them. Instead, the immense pressure of the ice, combined with geothermal heat rising from the Earth's core, has kept them in a liquid state, creating a habitat utterly unlike anything else on the planet. No sunlight reaches these hidden lakes, no winds disturb their surface, and yet, against all expectations, life has been found within them. Microbes that have adapted to an existence so extreme that it raises profound questions about the very nature of survival. These organisms, isolated for potentially millions of years, exist in a biosphere completely separate from the rest of the planet, living in total darkness, feeding off minerals and chemical reactions rather than sunlight. Their discovery has forced scientists to reconsider what life is capable of, not just on Earth, but beyond it. If such life can persist in the crushing blackness beneath Antarctica's ice sheets, then similar forms of existence might be hidden beneath the frozen crusts of Europa or Enceladus, waiting in liquid oceans buried beneath alien glaciers. But there is another, more unsettling implication of these ancient ice-covered worlds. If such isolated ecosystems have survived undisturbed for so long, what else might lie beneath the ice, waiting to be uncovered? The deep ice sheets erase all trace of what came before, but in doing so, they also preserve things in ways that defy understanding. The land beneath them has not seen the sky in tens of millions of years. The ice above it has recorded planetary shifts, frozen the remnants of past climates, sealed away entire lost landscapes. And yet, the more we uncover, the clearer it becomes that Antarctica is not a dead continent. It is simply one whose secrets have been buried so deeply that they have remained, until now, beyond our reach. 10. The risks of digging in ice. The ice conceals, but the more we reach into its depths, the more we risk disturbing what has remained undisturbed for millions of years. Beneath Antarctica's ice sheets, locked away in total isolation, are subglacial lakes that have never known the touch of sunlight or the presence of surface life. These lakes, sealed beneath miles of ice, are not merely ancient. They are pristine, untouched by anything from the world above since the time of the dinosaurs. The discovery of life within them has raised profound questions about survival in extreme conditions, but it has also brought a far more troubling realization. The moment we break through the ice, we may contaminate what has remained pure for an eternity. It is easy to assume that drilling into these hidden worlds is simply a matter of technology, of overcoming the physical barrier of ice. But the real danger is not just in reaching them. It is in what we might bring with us. Modern bacteria, microorganisms from the surface, microscopic life forms that thrive in our world but have never existed in the sealed ecosystems below. A single mistake, a single breach in sterile protocols, could introduce something foreign into an environment that has had no contact with the outside world for millions of years. And once contamination occurs, it cannot be undone. The balance of an ecosystem that has existed in complete isolation, unchanged for eons, could be disrupted in an instant. Scientists have gone to extraordinary lengths to prevent this. When drilling into subglacial lakes, they use hot water rather than mechanical drills, melting through the ice with sterilized, filtered water to avoid introducing foreign material. Instruments are carefully decontaminated, the drilling process meticulously controlled. But no system is perfect, and the deeper we go, the greater the risk becomes. If even a single bacterium from the surface makes its way into one of these lakes, it could either destroy what already exists there or, perhaps even more disturbingly, find a way to survive and spread. The fear is not just that we might introduce something harmful. It is also that we may not fully understand what we are disturbing. If life has persisted beneath the ice in isolation for millions of years, it has evolved separately from anything we know. Its biological processes, its adaptations, its very existence could be entirely unlike anything on the surface. What if, in our attempt to study it, we unknowingly alter it? What if we bring something back that should have remained buried? There is a growing awareness that these subglacial lakes are not just scientific curiosities, but fragile, irreplaceable worlds, places where even the smallest interference could have irreversible consequences. And then there is the possibility that what lies beneath the ice is not just life that has been sealed away, but something that has been trapped. The permafrost has already shown us that viruses and bacteria can survive being frozen for tens of thousands of years. What if the deep ice sheets hold pathogens from an age before humans existed? Organisms that thrived in a world we do not remember, preserved not just in ice, but in a kind of suspended time. The more we dig, the more we risk not just contaminating these ancient environments, but unleashing something from them, something we are entirely unprepared for. Antarctica's deep ice sheets are a final frontier, a world still untouched by human hands. But with every attempt to uncover its secrets, we must ask ourselves whether we are ready for what we might find, or what we might awaken. Bird Station, deep in the frozen heart of Antarctica, was never meant to last forever. Built in the late 1950s as part of the United States' push into polar research, it was a lonely outpost buried beneath layers of shifting ice. The men stationed there lived in a world where everything creaked and groaned, where the walls were never entirely still, and where time itself felt distorted by the unbroken expanse of white. But in 1965, something happened that served as a stark reminder of just how fragile human structures can be when set against the vast, restless forces of nature. A tunnel collapsed, not all at once, but in a series of failures, the ice pressing inward, reclaiming space that had only ever been borrowed. It was a lesson in how even the most carefully engineered designs were no match for the slow, inevitable movement of glaciers, the weight of countless years pressing down, shifting unpredictably, rendering every tunnel, every structure, every human effort temporary. For the men who lived there, it wasn't just an abstract engineering problem or a minor inconvenience. A collapse like that wasn't simply the destruction of a tunnel. It was a reminder of how utterly dependent they were on the integrity of the station, on the delicate balance between survival and catastrophe. The ice above them was not solid in the way that rock or soil might be. It was an ancient, slow-moving, deceptive kind of fluid, shifting in ways that no one could fully predict. When the tunnel walls gave way, it was the ice reminding them that it was still alive, still shifting, still unpredictable. And for those who had to crawl through the remaining passages afterward, feeling the weight of a continent pressing just above their heads, it was impossible to ignore the quiet knowledge that this could happen again, anywhere, at any time. The collapse raised unsettling questions about the stability of structures buried beneath Antarctic ice. If a tunnel at Bird Station could fail, what did that say about other research stations, about future projects, about the very idea of long-term habitation beneath the ice? There was something unnerving about realizing that the very ground they built upon was not truly stable. And if human structures were so vulnerable, what did that say about the ice itself? Could something as seemingly small as drilling trigger collapses on a much larger scale? Ice sheets, after all, are not static. They move, they fracture, they contain hidden voids and weaknesses that no amount of study can completely map out. The possibility that drilling could destabilize the ice isn't just an abstract fear. Ice cores, for instance, are drilled regularly to extract deep samples that reveal ancient climate records, tiny bubbles of trapped air offering glimpses into Earth's past. But the deeper you go, the greater the pressures become, and the more unpredictable the ice behaves. Some scientists worry that if drilling is done in the wrong place, or if an unexpected weakness is encountered, it could trigger collapses that are impossible to control. The deeper question is whether human activity, even in a place as seemingly untouched as Antarctica, is ever truly without consequence. We imagine the ice as something that has always been there, something that will always remain, but in reality, it is as dynamic as the oceans or the atmosphere, responding to forces both natural and human-made. The Bird Station collapse was, in some ways, a warning. Not a dramatic one, not the kind that captures headlines, but a quiet, creeping reminder that ice is not simply a frozen wasteland waiting to be explored. It is something alive, something restless, something that will not be held back forever. The people who lived there understood this in a way that few others ever will. They felt the ice shift beneath them, heard it groan in the night, saw the way their own presence barely registered against the weight of millennia. The tunnel collapse was not just an isolated event. It was part of a much larger story, one that scientists, engineers, and explorers are still trying to understand today. 11. Ice drilling and space exploration. That uneasy relationship between human structures and the ice is part of why Antarctica has become such an important testing ground, not just for Earth's own mysteries, but for what lies beyond it. If building and drilling here are already fraught with uncertainty, how much more difficult would it be on another world? That question is not theoretical. NASA and other space agencies have been using Antarctica as a stand-in for alien environments, a place where machines and methods meant for deep space can be tested under some of the most extreme conditions found on Earth. Ice drilling, in particular, is one of the most critical challenges, not only for exploring the frozen depths of Antarctica, but for one day searching beneath the icy surfaces of places like Mars, Europa, or Enceladus. Moons that might hold secrets locked away beneath layers of ice. Drilling into ice in Antarctica is not just about getting through a frozen surface. It is about understanding what lies beneath, how layers of ice form over time, how fractures and pressure affect the way ice responds, and how deep one must go before reaching liquid water. In space exploration, these same questions take on an even greater weight. Beneath Europa's ice, there may be an ocean teeming with microbial life, hidden away in the dark for millions of years. But to reach it, humans would need to send a machine capable of withstanding crushing pressures, bitter cold, and unpredictable ice movements. Testing such technology in Antarctica is the closest thing we have to a real-world trial, an opportunity to refine the process before sending a machine billions of miles away, where failure would mean losing a mission entirely. Scientists and engineers who work in Antarctica know how unforgiving the environment can be. The ice does not simply sit there, waiting to be studied. It fights back. Drills freeze over, equipment malfunctions in the cold, delicate instruments struggle to function when surrounded by endless moisture and shifting ice. The people working on these machines must learn patience, problem-solving, and resilience, knowing that every setback teaches them something about how their machines will behave on another world. These teams live in isolation for months at a time, battling not just the physical challenges of working in the ice, but the mental and emotional strain of being cut off from the rest of the world. In this way, Antarctica does not just test technology. It tests people. The loneliness, the reliance on a small crew, the inability to escape the environment. All of these things mirror what astronauts will experience on Mars, where even the smallest error could mean disaster. The drilling robots NASA is developing are unlike anything used in traditional ice core studies. Some are designed to melt their way downward, using heat to carve a path through the ice rather than brute force. Others are equipped with sensors that map out structures beneath the surface, helping scientists predict where the ice might be weakest or where liquid water may be hiding. One of the most ambitious designs is a probe meant for Europa, a machine that would slowly tunnel through miles of ice using nuclear heat, carrying a smaller robotic submersible that could eventually be released into the hidden ocean below. Before something like that can ever be deployed, it must first survive testing in Antarctica, where researchers set up in the most remote regions, drilling deep into ice sheets to see if their machines can handle the unpredictable conditions. Every drill that gets stuck, every unexpected fracture, every frozen component is another lesson in what might happen when we finally send these machines to other planets. The ice in Antarctica is constantly shifting, not entirely solid, sometimes concealing lakes of liquid water miles beneath the surface, places that might resemble the subsurface oceans of Europa or Enceladus more closely than anything else on Earth. If we cannot figure out how to successfully drill here, in conditions we can study up close, then we have little hope of succeeding when the target is a distant moon orbiting Jupiter, where signals take minutes to reach and every mistake is magnified by the impossibility of a quick fix. For the scientists involved, the work is not just about solving technical problems. There is something larger at stake. The idea that beneath the ice of another world, something might be living, something that has never been seen before, something that could change the way we understand life itself. That possibility is what drives them forward. The people who spend months in Antarctica testing these machines, troubleshooting their failures, standing in the frozen silence of the most alien place on Earth, understand that they are preparing for a future where humans may one day reach beyond this planet and drill into the unknown. Antarctica is not just a place to study ice. It is a proving ground for the future, a place where, step by step, we are learning how to explore the unreachable. The idea of drilling through the ice of another world isn't just theoretical. It has already begun, in the only place on Earth that even remotely resembles the frozen landscapes of Europa. After years of planning, the European Space Agency took its experimental ice drill to Antarctica, testing whether it could survive the kind of extreme conditions it would one day face on a distant moon. It wasn't just about proving the drill could function in the cold. It was about seeing how it handled the unexpected, how it reacted to real ice formations, how it coped with the unpredictable nature of a frozen environment that was constantly shifting in ways no lab could ever fully replicate. The people involved knew that if their machine failed here, it would never survive the far harsher realities of Europa. There is a kind of patience required in this kind of work, a willingness to wrestle with every failure, knowing that every jammed mechanism, every frozen drill bit, every system shutdown is another lesson in what will go wrong when there are no second chances. The team had to live with the machine, maintaining it, repairing it, learning its weaknesses the hard way. Antarctica gave them no room for mistakes. Equipment broke down simply from the unrelenting cold and drilling through real ice. Ice that had been compressing for thousands of years. Was nothing like running tests in a controlled lab. There was pressure, movement, hidden fractures, unexpected densities. If the drill became lodged in the ice, if a sensor malfunctioned at the wrong moment, if even one component failed, the entire test could be lost. But they pushed forward because they weren't just testing a drill. They were testing an idea. The belief that humans could one day send a machine across billions of miles of space, drop it onto the frozen surface of Europa, and have it carve its way through miles of unbroken ice until it reached the hidden ocean below. That ocean is one of the most tantalizing mysteries in our search for life beyond Earth. It has likely existed for millions of years, untouched by sunlight, warmed only by the internal heat of the moon itself. If life exists anywhere beyond Earth, it could be there, beneath the ice, hidden in the dark. The only way to know for sure is to find a way to break through, to send something down into those waters, to listen, to search. The drill ESA tested in Antarctica was a step toward that goal. It was designed to burrow through thick ice autonomously, navigating its way downward while sending data back to the surface. Unlike traditional drills, which rely on brute force, this one had to be precise, controlled, capable of analyzing the ice as it moved through it. The test was not about speed. It was about survival. Would the drill keep working after days, weeks, months in the cold? Could it extract samples without contaminating them? Could it operate in total isolation, with no one there to fix it if something went wrong? The engineers overseeing the project knew that on Europa, there would be no second chances. If something failed, if the drill became stuck, if a component froze solid and refused to function, there would be no one to retrieve it, no way to send help across the vast emptiness of space. The test was grueling, but it was necessary. The people who worked on the drill understood that their time in Antarctica was more than just an experiment. It was a glimpse into the future, a rehearsal for a mission that might not happen for decades, but would one day change the way we see the universe. They stood in the silence of the frozen landscape, surrounded by ice that stretched as far as the horizon, and knew that, in some distant future, a machine like this might be drilling into the ice of another world, cutting into a place no human had ever seen, reaching down into the dark, searching for something that had been waiting beneath the surface for longer than we can imagine. 12. The future of ice drilling. The drill ESA tested in Antarctica was just one piece of a much larger effort. An effort that extends not only into space, but deeper into the ice itself. The more scientists drill, the more they realize that the frozen layers beneath their feet hold stories far older than anything written in human history. Every core extracted from the depths of Antarctica is a time capsule, preserving snapshots of Earth's past in tiny bubbles of air trapped when the ice first formed. But there is a limit to how far we have gone, and that limit is something researchers are determined to push beyond. The next great challenge is to drill even deeper, to reach ice that formed more than 5 million years ago, a discovery that could fundamentally change how we understand Earth's climate, its history, and perhaps even its future. There is something almost paradoxical about ice that ancient. To the people who live and work in Antarctica, ice is always moving, always shifting. They hear it cracking, expanding, breaking apart. It never seems permanent. And yet, hidden far below, there are layers that have remained undisturbed for millions of years, buried so deeply that they have survived everything that has changed on the surface. To reach that ice is to reach a version of Earth that no human has ever known, to touch something that existed before the first ancestors of modern humans walked the planet. The scientists working on these new drilling projects are driven by the knowledge that deep within that ancient ice, there are secrets waiting to be uncovered. Evidence of how the planet's climate has shifted over eons, clues to how the atmosphere has changed, a record of Earth's history written in frozen layers. But drilling that deep is not simply a matter of using bigger, stronger equipment. The pressure at those depths is immense, and the ice itself behaves differently under such conditions. It is no longer just frozen water. It is compressed, transformed, altered by the weight of the ice above it. The deeper scientists go, the more unpredictable the ice becomes. Some layers are harder than expected, others softer, some so filled with trapped gas that drilling into them risks disturbing the very samples researchers are trying to preserve. The deeper they go, the greater the risk of contamination, of losing the very information they are searching for. And yet, they continue, because the deeper they drill, the further back in time they can travel. The people working on these projects are not just engineers and scientists. They are explorers in the truest sense. They work in some of the most isolated, brutal environments on Earth, spending months in the cold, monitoring equipment, analyzing ice samples, knowing that a single miscalculation could mean losing months or even years of work. They wake up each day knowing that beneath their feet is a world that no one has ever seen, a frozen archive of time itself, waiting to be read. And they know that if they succeed, if they can reach ice that is millions of years old, they might be able to answer questions that have haunted climate scientists for decades. How stable is Earth's climate over long timescales? Have there been periods of warming and cooling that we don't yet understand? Could the past offer warnings about what the future holds? The deeper they drill, the more fragile the samples become. At those depths, the ice is under such pressure that even the act of bringing it to the surface can alter it. Every piece extracted must be handled with extreme care, transported in conditions that preserve its exact state, studied before it can begin to change. And yet, for all the challenges, the scientists believe it is worth the effort. They believe that hidden deep within the Antarctic ice, there is knowledge that could reshape our understanding of the world, knowledge that could help predict what is coming. There is a kind of poetry to it, digging into the past to understand the future. The ice, silent and ancient, holds answers we have not yet learned to ask. And the people drilling deeper and deeper into its depths are not just searching for records of a vanished world. They are, in a way, searching for ourselves, for the long thread of history that connects the distant past to the uncertain future. Digging into the past to understand the future is not something that happens only on Earth. While scientists in Antarctica push deeper into the ice to uncover ancient climate records, others are preparing to send a mission to one of the most mysterious ice-covered worlds in the solar system. NASA's Europa Clipper, scheduled to launch in 2025, will not drill into the ice itself, but it will search for something just as elusive: the hidden ocean beneath Europa's frozen surface. It is a mission built on decades of speculation, on the tantalizing hints gathered from past flybys, on the belief that under miles of unbroken ice, there may be a world of liquid water unlike anything we have seen before. Europa has long been one of the most compelling places in the search for extraterrestrial life. Unlike Earth, where the sun provides warmth and energy, Europa's ocean is thought to be heated from within. Tidal forces from Jupiter's immense gravity pull at the moon's interior, generating heat, keeping the water beneath the ice in a liquid state. On Earth, deep in the oceans, where sunlight never reaches, life thrives around hydrothermal vents, sustained not by the sun, but by the chemical energy released from within the planet itself. If the same processes exist on Europa, then it is possible, just possible, that life may have found a way to survive there too. The Europa Clipper will not land. It will not drill. It will not melt its way downward in search of water. Instead, it will fly past the moon repeatedly, mapping its surface in unprecedented detail, scanning the ice with powerful instruments, searching for signs of subsurface water, and, perhaps, for clues that something may be stirring beneath. It is the first step, the reconnaissance mission that will tell scientists where to look next. Its instruments will measure the thickness of the ice, detect any hints of plumes erupting from beneath the surface, and analyze the chemical makeup of the frozen world it passes over. If Europa is leaking traces of its hidden ocean into space, the Clipper may be able to capture those molecules, analyze them, and determine whether they carry the complex chemistry that could hint at life. For the scientists who have spent years working toward this moment, the mission is a mix of excitement and frustration. It will tell us more about Europa than we have ever known before, but it will not answer the biggest question. It will not confirm whether something is swimming beneath that ice, whether life has taken root in an alien ocean. That answer is still decades away, dependent on future missions, on landers, on drills that do not yet exist. And yet, every great discovery begins with the search, with the long and careful process of understanding a place before reaching into it. The Clipper is the next step, the moment when Europa stops being a distant mystery and becomes a world we can study in depth. There is something profoundly human about the way exploration works. We start from afar, we send machines to observe, to gather information, to prepare for the day when we finally arrive. The people who built the Europa Clipper know they will not be the ones to find life if it exists there. They know that this is the beginning of something larger, that they are laying the groundwork for those who will come next. But they also know that without this step, there can be no next step. If life is waiting beneath Europa's ice, it has been waiting for millions of years. It will wait a little longer. But with each mission, each flyby, each new image and measurement, we are moving closer to the moment when we will finally know what is hidden beneath that frozen shell. The search for life beneath Europa's ice is a reminder that some forms of existence remain hidden for millennia, locked away in frozen landscapes, waiting for the right moment to be discovered. But not all frozen secrets belong to distant moons or deep time capsules of climate history. Some of them are closer, buried beneath the permafrost, preserved in ways that almost defy belief. In Siberia and other Arctic regions, as the ice retreats and the ground thaws, creatures that have been extinct for thousands of years are emerging. Intact, frozen, and in some cases, so well preserved that their flesh is still red, their fur still clings to their bodies, and their DNA remains almost shockingly intact. For scientists studying de-extinction, this is more than just a glimpse into the past. It is an opportunity to ask a question that has haunted biology for years. Could a species like the woolly mammoth be brought back to life? The idea of reviving an extinct species is no longer just science fiction. Geneticists have already sequenced the full genome of the woolly mammoth, piecing together its genetic blueprint from frozen remains. The next step is not simply about cloning, because cloning requires a living cell, and after thousands of years, the cells of these mammoths are broken, their DNA fragmented. Instead, scientists are using a different approach, one that involves taking the closest living relative, the Asian elephant, and editing its genome, modifying its DNA piece by piece to resemble that of a mammoth. It is a slow, meticulous process, like reconstructing a shattered artifact, but each breakthrough brings them closer to the possibility of creating an animal that is not quite a mammoth, not quite an elephant, but something in between. For the researchers working on these projects, the goal is not just to see if it can be done, but to explore whether it should be done. They argue that reintroducing mammoth-like creatures to the Arctic tundra could help restore an ecosystem that has been slowly unraveling since their extinction. The mammoths once shaped their environment, trampling snow, uprooting trees, creating grasslands that helped lock carbon into the soil. Without them, the tundra has changed, and some scientists believe that bringing back large herbivores could help slow the thawing of the permafrost, preventing the release of massive amounts of greenhouse gases trapped beneath. The mammoth, in this view, is not just a relic of the past, but a potential tool for shaping the future. But it is not that simple. Even if the technology succeeds, even if a living, breathing mammoth-like creature is born, it will not be stepping back into the world it once knew. The ecosystems have changed. The other species it lived alongside are gone. There are no ancient herds to join, no instinctive paths to follow. The first mammoth to walk again, if it ever happens, will be a singular creature, a product of both science and speculation, existing in a world that has moved on without it. And then there are the ethical questions. What does it mean to bring back a species that has been extinct for thousands of years? Is it truly the same species if it has been engineered rather than reborn? Would a living mammoth be a success story or a scientific curiosity? An animal that exists not because nature sustained it, but because humans willed it back into being? The people working on de-extinction projects wrestle with these questions every day. They are drawn to the challenge, the possibility, the implications of what it could mean for the future of conservation. If we can bring back a mammoth, what about other species? Could this technology help rescue animals on the brink of extinction today? Could it be used not just to look backward, but to protect what is still here? The answers are uncertain, but the pursuit continues because frozen in the permafrost, in the fragmented strands of ancient DNA, there is a chance, however small, that something lost to time might one day walk again. The idea of bringing back something long buried in ice, whether it is a species lost to extinction or a record of Earth's ancient past, is a reminder that frozen landscapes are more than just remnants of the cold. Ice has always been more than just frozen water. It is a vault, a time machine that preserves what would otherwise be erased by time. It holds within it the breath of ancient atmospheres, the movements of long-forgotten climates, the remains of creatures that once roamed a world vastly different from our own. It is one of the few natural archives that can hold on to something for thousands, even millions, of years, and when we drill into it, when we analyze the layers, when we extract the fragile molecules trapped inside, we are not just looking at ice. We are looking at time itself. For all its stillness, ice is not static. It flows, it fractures, it shifts under its own immense weight. It carries things forward, buries them, reveals them again when the conditions change. It is both a preserver and a destroyer, capable of protecting ancient secrets while also grinding away at mountains, carving landscapes, reshaping the world. In its depths, we find traces of life that existed before human civilization, bacteria that have been dormant for millennia, whispers of ecosystems that have long since disappeared. Ice has locked away pieces of the planet's past that would have otherwise been lost, and each time we drill deeper, each time a glacier melts to expose something unseen for tens of thousands of years, we are confronted with the reality that the present is only a thin layer resting on top of an unimaginably vast history. But ice does not only tell us about Earth. It also holds clues about the universe beyond. In the search for life elsewhere, we look to frozen moons, to the ice-covered oceans of Europa and Enceladus, to the ancient ice caps of Mars, to the comets that streak through space carrying frozen water that may be as old as the solar system itself. The same ice that preserves Earth's history may also hold answers about how life began, how planets change, how water moves through the cosmos. And just as we drill into Antarctica to uncover the story of our own world, we send probes to icy moons, hoping that beneath their frozen crusts, something remarkable is waiting. Ice is a paradox. Something that seems lifeless yet holds traces of life. Something that appears unchanging yet is constantly in motion. Something that seems to belong only to the past, yet remains deeply connected to the future. As we explore deeper, as we search further, as we look beyond Earth and into the cold reaches of space, ice continues to be one of the most valuable storytellers we have. It does not speak, but it holds on to everything. And for as long as it remains, there will always be something more to discover. If ice holds on to everything, history, life, the echoes of ancient climates, then every time we drill into it, we are reaching into something fragile, something that has remained untouched for longer than human civilization has existed. The deeper we go, the further back in time we push, uncovering secrets that have been locked away in the cold. But with each core sample taken, with each probe sent beneath the surface, the question lingers. Are there places where we should not drill? Are there layers of ice that should remain undisturbed, records that should be left unread, ecosystems that should not be exposed to the modern world? There are places on Earth where the ice has sealed away not just knowledge, but life itself. Ancient bacteria and viruses that have remained frozen for thousands, even millions of years. Some of these microorganisms could be harmless, relics of a past era, incapable of surviving in today's world. But others might still be viable, still capable of spreading, still adapted to an environment that no longer exists. As permafrost thaws, as glaciers retreat, as drilling projects push deeper, the possibility of awakening something long dormant is not just a distant hypothetical. Scientists have already revived microbes from ice tens of thousands of years old, and while most have posed no threat, the reality is that we do not fully understand what might be buried deeper, beyond anything we have yet uncovered. Then there are the places that have remained isolated for so long that they may hold ecosystems entirely unknown to science. Beneath Antarctica's ice, hidden under miles of frozen weight, are lakes that have not seen the surface in millions of years. These are not just pockets of trapped water. They are entire environments, untouched, self-contained, where microbial life may have evolved along a completely separate path from the rest of the world. Scientists have carefully drilled into some of these lakes, sterilizing their equipment, taking every precaution to avoid contamination. But each time we breach the ice and enter a place that has been sealed for millions of years, there is a risk of introducing modern microbes to an ancient ecosystem, of destroying something before we even understand what it is, of disrupting a natural balance that has existed in isolation for longer than we can comprehend. And beyond Earth, there are the frozen worlds where the greatest discoveries may still be waiting. If Europa or Enceladus hide life beneath their ice, if there is something surviving in the dark oceans beneath their frozen crusts, then the moment we send a drill, the moment we break through, we are making first contact with an alien ecosystem. The consequences of that, biologically, ethically, philosophically, are impossible to predict. What if we introduce Earth's microbes to a pristine extraterrestrial environment, forever altering it before we even understand what was there? What if we bring something back that we are not prepared for? The search for life beyond Earth is built on curiosity, on the drive to understand, but it is also built on responsibility. The moment we pierce the ice of another world, we are no longer just observers. We become a force of change, for better or worse. There is a thin line between exploration and intrusion, between discovery and disruption. The ice holds stories that we are desperate to read, but some stories may not be meant for us to uncover. Not yet, not without caution, not without the awareness that once something is disturbed, it can never be put back exactly as it was. Science moves forward because we ask questions, because we seek answers, because we refuse to let mysteries remain unsolved. But perhaps the hardest question of all is not whether we can drill, but whether we should. And that's where we leave the frozen depths, for now. We've drilled through time, uncovered secrets buried for millions of years, and maybe even raised more questions than we answered. Ice is more than just frozen water. It's a vault of history, a graveyard of forgotten life, and possibly a key to our future. Whether it's lost civilizations, ancient viruses, or the possibility of life on distant worlds, every drill into the ice is a step closer to unraveling Earth's most hidden stories. If you enjoyed this journey into the unknown, don't forget to like the video. It helps thaw the cold and hard algorithms. And if you want more deep dives into the mysteries of our universe, consider subscribing. The quiet universe is always here, waiting to take you further. Until next time, stay curious, stay warm, and keep looking beneath the surface.